Hello, everyone, and welcome to today's webinar titled Discover Nutanix with VMware ESXi Hypervisor. My name is Michelle, and I will be your MC for the hour. Thank you for joining the conversation. Before we get started, let's cover the webinar functionalities. During the session, everyone's microphones will be muted, but we want this to be an open discussion. So if you have any questions or comments, please enter them in the Q&A box or the chat window at the bottom of your screen. There will be a dedicated question and answer session after the presentation, but we encourage you to drop those comments in along the way. Today's webinar is being recorded and a copy will be sent out to everyone near the end of the week. Our speaker today is Ken Willard. Ken specializes in system virtualization and consolidation at the server and desktop level, helping technology teams approach virtualization while considering the technical, organizational, and political impact. Ken has worked with IT organizations from the commercial, government, and nonprofit verticals, addressing virtualization in each of these unique environments. In addition to delivering training to both the business partner and end user communities, Ken also works with the tech data channel community to assist with pre-sale consulting. We're in for an informative discussion and a real-time demo today, so let's get started. Ken, you can take it from here.
Thanks, Michelle. Welcome, everyone. So a little bit of a hot topic these days, right, as folks are looking at hyperconverged environments and what that means for them in choices of infrastructure. And frankly, today, a lot of emphasis on automation and looking at how the data center is going to change and evolve over the next probably 3 to 5 years. So as Michelle talked about, we're going to open up. We've got a general presentation. We're going to talk a little bit about some of the new news out of Nutanix recently, a little update from late in last month. We're going to talk about just some of the trends that have been going on in general over the last few years. Honestly, nothing that many of you don't probably already know, but just do a little bit of review, kind of set the framework for how we got to the hyper-converged conversation that many of us are having today. And then finally start drilling into some of those specifics about what's going on with the Nutanix distributed storage fabric platform and how that interacts specifically with the VMware ESXi Hypervisor. And then as discussed, we'll have a little bit of a live demo. We've got a demo environment set up. We'll be talking about the management platforms, and we'll be doing a little bit of work with some virtual machines just very quickly to show you some of the capabilities with the different ones of the management platforms. So as we look at what's new, kind of the big news last month, about the third week of September, we got the announcement of Nutanix releasing the Acropolis OS version 6 release. And by the way, just so that everybody's kind of clear, right? There's a lot of vocabulary around any IT product or solution. When we think about that Acropolis OS, when Nutanix makes that recommendation, right, what they're talking about is the software that's running inside of your CVMs. And it doesn't matter which hypervisor you're working with, there's always a CVM, one CVM per node with the Nutanix architecture. And so it's that Acropolis OS. It's the makeup and the code base that's running inside of your controller VMs on each node in the cluster. And that's what's delivering our data services. That's what's delivering the clustered storage architecture for us, right? So obviously a critical part of the architecture. The other thing that may be a little different for some of you, particularly thinking about how other vendors handle their release schedules and what's going on, the AOS release 6, so the whole number incremental release, is a short-term support release from Nutanix. Nutanix does their support model in two different configurations. There's the long-term support release, which is intended to, just kind of like its name implies, be the long-term stable release of the platform. And just to be candid, we generally think about that in organizations that are a little more conservative in their IT operations. They tend to want to have a single cluster upgrade done and have that cluster upgrade be able to be viable and run long-term for many months or a year. All right, and so with the long-term support model, that's what you get. And then inside of the long-term support releases, you'll get patches or security updates and those kinds of things. So it's not that with the long-term release, you don't have any more patching to do, but you've got a stable code base that is intended to be run long-term. And the current long-term support release from Nutanix is the 5.20 release. So what do we get with these short-term releases? Right, the whole thing from the Nutanix perspective is the short-term support releases are feature set releases. You will get new capabilities, new things that get released, and if you want them right away, you can roll out that short-term support release. And it doesn't commit you to one path or another, right? This is another conversation that I have with customers that they say, well, so if I go to the short-term support release, then I have to stay there. Well, you stay there until such time as the next long-term support release comes out, and then you can shift the model back, right? It's interesting that we're talking about ESX here. This actually happened with several customers that I worked with back when vSphere 6.7 was released. So obviously a few years ago, but the then long-term support release didn't support vSphere version 6.7. So those customers moved on to a short-term support release to get the vSphere 6.7 hypervisor support. And then when the next long-term support bundle came out, they rolled right back to the LTS model. So you have your choices, right? You can manage that so that it stays in line with your own IT practices. Sort of some of the big hitters, right? And this is a very short list of what we got in the 6.0 release, but some things like replication factor 1, right? And if you're kind of thinking about, why would I want less replication factor capability, right? Why would I want less redundancy of my data? The thought here is we often have things that are doing some kind of application level clustering. Active Directory is a great example of that. You're not going to deploy a single Active Directory controller VM into an environment. You're going to deploy, generally with CVN in small shops, a minimum of 3, oftentimes more. Well, if I'm already deploying multiple copies of a service or an application within my environment, I don't necessarily need multiple copies of that data on disk as well. So we now have the ability to store virtual machines in a replication factor 1. In other words, no on-disk redundancy of that virtual machine data, but it's intended to support those environments where you're running multiple copies of a particular VM or a particular application build anyway, so you're not double investing in that on-disk storage, right? Those kinds of things. Metadata rewarming, this is an interesting one, right? We've always had the idea of the metadata behavior, but when we look at events like virtual machine migrations or vSphere HA events where a virtual machine is restarted on another host, we could actually see a little slowdown in the performance of that VM for a little bit because the metadata about that VM might not be readily available on the node where that VM was running, right? We think about the metadata, again, those Cassandra database services, and that's a distributed model. It runs across multiple nodes of the cluster architecture for that redundancy and resiliency purpose. So now when we have something like an HA restart event, or even just a simple vMotion migration of a VM for maybe DRS load balancing rules, the metadata for that VM will get rewarmed on the new node as well, and we see bump in performance. The autonomous extent store, there's quite actually a big conversation around that one that we could get into if anybody was interested maybe during the Q&A. But the idea behind the autonomous extent store, we have talked about data locality from the beginning of the Nutanix architecture. But again, kind of following on that metadata rewarming conversation, the Cassandra metadata for your virtual machines was a distributed model. And so we could sometimes see some performance hits, particularly when we were ingesting large sets of data. You're thinking about something like a Hadoop big data analysis environment, and you're building it out for the first time and populating the data sets, or you're building out one of the on-premises data lake architectures. And so you're bringing in large data set ingestion. The fact that the Cassandra metadata database architecture was distributed, there was no concept previously of that metadata existing just on one node to start with and then being able to be made redundant after the fact. It was always distributed right from the start, which meant we paid a little bit of a write latency performance hit around those events. Then with 5.10, we got what was called the autonomous extent store. And if your cluster had at least 8 solid state devices or any one NVMe device per node, the autonomous extent store could keep a primary copy of the metadata locally as we were ingesting large sets of data, and then worry about the redundancy after the fact. And it produced a massive performance increase in bringing in those large data sets. But the trick to the autonomous extent store, I guess the catch is maybe the better way to say that, it originally only worked in brand new clusters. We now have what they're calling the autonomous extent store brownfield implementation. That is, if you're going through a progressive hardware upgrade, maybe just upgrading the number of disks in your nodes or the NVMe architecture of your nodes, the autonomous extent store can now be activated in those clusters that previously did not meet the hardware configuration when they were created, right? And that was previously not an option. It only could be done when you built the cluster. A little bit on the Acropolis Hypervisor Metro availability conversation. I mentioned that simply because there's 2 things at play here. When we think about Metro support, the Metro behavior, that Metro function gives us 0 recovery point objective. I want to make sure I was using the right acronym there. It's real-time replication of the data between 2 clusters. We've always had a Metro architecture because on the ESXi Hypervisor, because it tied into the native ESXi high availability services. The reason I brought this up in this particular presentation is because a lot of you are looking at running both ESXi and Acropolis Hypervisor today. You may have some sites where you're picking one hypervisor or the other because of cost and functionality decisions. And so we had historically been able to do synchronous replication with the Acropolis Hypervisor, but not the Metro management. Right? And the thing about the Metro availability distinction is it leverages high availability services of the hypervisor to automatically do failovers if we have a failure of one of the 2 sites that's replicating. So for those of you that are looking at those 0 downtime events from a data set, and a near 0 downtime recovery window for your recovery time objective, you can now do that with both ESXi and the Acropolis Hypervisor. And then finally, the last bullet up there is the fact that near sync has been expanded to support multiple sites, gives you a much better failover model. And folks, this is a tiny snippet of the Acropolis OS version 6 announcement. So I just posted the link to the full announcement in the chat window. We've got a few slides that kind of do some background work. And honestly, we're going to move through these really quickly because I don't think there's anything that's new or revolutionary here. This is stuff that we all know. We've kind of seen this evolution of the data center from client server to virtualized. And frankly, a lot of the impact was on storage and networking infrastructure, changing from, frankly, a little slower transaction rate things to workloads that are much higher transaction rate on the disk architecture, and workloads that instead of being what we traditionally think of as north-south traffic for communication, a lot of east-west, right? A lot of density of communication between VMs, sometimes on the same hypervisor, sometimes hopping hypervisor to hypervisor adjacently. And so that has all kind of snowballed. Then, of course, we're finally into this cloud concept architecture, where folks are using cloud as this really broad, really generic umbrella, but it sort of helps us start to define, especially the more we think about automation in the data center and putting management systems in front of our environment that can do REST API calls or even scripted automation calls, and making that much cleaner and being able to support density of data and density of network communication. That's kind of where we've seen this come from. Webscale, I'm going to spend nearly no time on this, right? We know what this means. The number of VMs and the responsiveness of either recovery or the ability to deploy new workloads continues to grow. And when you think about the big cloud providers or those very cloud-centric applications like Facebook, they've driven a lot of innovation in that. Right? And so it's based on, frankly, cheap commodity x86 hardware, and yet being able to ensure very high performance and very high reliability with ideally inexpensive hardware. And we want to get to a space where we are being able to leverage more automation, because as we think about some parts of the application may run on premises, some parts of the application may run out in the cloud, the firewall, the network, even the backend storage performance configuration can get more and more complex. All right, and this also sort of moved us into this idea of trying to simplify complexity, not just in operations, but when we think about hyperconverged, right? This is really talking about simplifying that complexity specific to storage. We think about the traditional, what most folks consider the three-tier model, right? You had your compute layer where the execution of the code was being run. We often had some kind of a dedicated storage infrastructure or storage fabric if you come from that industry. And that was letting those compute resources talk to then some back-end traditional storage area network or network attached storage appliance that delivered your storage network. And obviously today, we're looking at a lot of converged architectures where we're bringing the disk right into the same chassis that's delivering compute and networking. It gives us more flexibility. It gives us the ability to scale capacity at the same time. When we think about hyper-converged architectures and how they deliver specifically disk resource, the performance is handled and measured wildly differently. Nutanix specifically not only helps us address what we think about as the storage concerns, but a lot of things like business continuity concerns, right? Frankly, everything over here in this second column is primarily talking about business continuity concerns. Everything kind of on the right side of the enterprise storage section of this slide is talking about the data efficiency and the data performance capabilities, right? And I just mentioned, actually now not listed on the slide, the ability to do the RF1 configuration. So if you're running effectively multiple copies of the same application VM because they're doing some kind of application level clustering, it doesn't always make sense to keep multiple copies of those multiple VMs on disk. We can be more efficient about that. Big part of any conversation today, when we think about the growing virus threats and things that are particularly damaging to operations like crypto locker viruses, the Nutanix approach, security first, they actually have, if you've read much of their documentation, you know what they have, they call the security development lifecycle, right? It's not software development, it is security development, because as their DevOps team creates new functions, makes changes, upgrades, and additions to the Acropolis OS environment, that gets tested at every phase. It's not just a post-compile, how does this work now that it's all built? Right? So a lot of emphasis on security all the way through not only the stack itself, so far as the pieces that you would be managing as the infrastructure team, but right from the development standpoint as well. All right, so as promised, try to move through those very quickly to get into the real VMware and Nutanix conversation. Right, so what parts of the VMware software environment, software stack, are supported on Nutanix? And if you go out and pull the documentation, right, these are the components. So core vSphere, the vCloud suite, and Horizon View. And in my mind, it often becomes something that folks think about as a separate product, but it's kind of implied in the vCloud suite, right? NSX is on that supported list as well, but it's actually interestingly kind of not listed as an independent thing or an independent supported product when you look at the documentation. So for most organizations today, it's sort of the first and the third, right? They care about core server virtualization. And then obviously, if they're working on virtual desktops, which has been more of an emphasis over the last 18 months, right? Horizon View fully supported there. So those are the software components or the software stacks that are supported on the Nutanix distributed storage fabric. When we look at vSphere specifically and break down what functions of vSphere are supported, folks, it's all the stuff that we would want to do, right? Anything that we would do in any other storage-backed vSphere architecture, we're going to get with the Nutanix distributed storage fabric solution running the ESXi Hypervisor. And I think the big one where this really comes into play, in my mind, where the value proposition is here in the support for the vSphere APIs for array integration. What is that, right? If you've not dug into the vSphere environment a lot, it is simply a mouthful to say vSphere can hand off a particular storage task to the distributed storage fabric, to the storage array, let it do the storage work, and then simply reply when the REST API request is completed. There are functions that we think about. The ESXi hypervisors have to historically spend CPU time so that the VM kernel can do this actual storage work itself. When we look at environments where the APIs for array integration are supported, that work gets handed off to the storage engine. Now, you make the case in the perspective of Nutanix, technically that still means we're spending some CPU cycles because that workload is getting handed off to the CVM, but we get then access to those additional behaviors. And the big one is really in cloning operations. I don't have time in this short window to dig a ton, but there are substantial differences in the way the distributed storage fabric handles cloning and snapshotting versus the way that a native ESXi clone or snapshot would be invoked, simply based on the fact that ESXi had to be built to work with multiple storage vendors, right? They had to have sort of an agnostic way to implement those two features that would work across third-party storage vendors. But when we leverage the APIs for array integration, we can leverage those really specific Nutanix behaviors. And if you've not seen this, in short, the way this works is I have my base VM, and it has out on disks what Nutanix refers to as extents. When we think about traditional storage, a lot of times we think about the smallest unit that we're managing is called a block. When we're talking about the distributed storage fabric, that's called an extent. We then have the metadata architecture, that Cassandra metadata architecture that's so critical to the distributed storage fabric. It's what points us to those extents on disk, right? We build what's called a disk map that tells us what extents on disk are owned by a particular VM. When I go to do a cloning or snapshot operation through the distributed storage fabric architecture, and let's just talk cloning for the sake of this conversation, what I can do is I can mark all of the current extents on disk as read-only. I can then create a new virtual machine. And initially, for a short period of time, it can share all of the exact same extents on disk. When it first starts up, its disk map is identical. And then obviously, if those two VMs are powered on and continuing to run, their on-disk condition will diverge over the course of normal operation. But we can just leave those extents that are still common and shared between the two. We can keep a single copy, and we can repoint their disk map to different extents when they need to create updates. Right, and that is a really quick, really oversimplified version of how the Nutanix distributed storage fabric handles that real efficiency on disk. And you can get to that behavior through vCenter, right? You don't need to be using Prism or Prism Element or Prism Central to do that. When you clone right from within vCenter, you can get access to that really efficient model on disk. But the catch is the VM must be powered off. Maybe sounds like something I'm going to use a template for. Sound right? And it may not have snapshots, that is vSphere-based snapshots in place if I want to leverage these APIs for array integration and that behavior. Right? If the VM is outside of those two requirements, so if it's powered on or if it has vSphere-based snapshots in place, the system automatically shifts over and goes back to the traditional ESX will manage the on-disk operation for us. A little bit on that so far as exactly when you get the benefit of using the APIs for array integration is detailed really well in the Nutanix Bible. And so I just posted into chat the specific link that talks about how Nutanix and when the Nutanix API for array integration gets invoked. So those are kind of the conversations around the products and features from the VMware side that are supported on top of the distributed storage fabric. What if we look at this from the other perspective? Right, a lot of organizations are starting to look at the other things that are available from Nutanix. So what other Nutanix services or functions can we support on top of the ESXi Hypervisor? When we look at the three, what Nutanix calls their data services, right? These are the three data services that can be delivered from your distributed storage fabric-based cluster. If you're not familiar with these Nutanix volumes, these are iSCSI targets. Nutanix files is just exactly what you would think. Hang on, I've really messed myself up. Let's try this differently. Give myself a little more room to work with here, right? iSCSI targets, files, NFS, and SIFS shares. Let's just say SMB shares, it's faster to write. And then buckets are object stores. We can run all of those types of data services, and obviously each one of them have very different use cases around when you might want to use one or the other, but they are all three from a data services standpoint supported with VMware. And then lastly, of course, Calm. Anybody started looking at this? The cloud application lifecycle manager tool. This is a function of Prism Central. And to be really specific, you have to be, no, you don't have to be running Prism Central Pro. You can get this with Prism Central as an add-on, right? If I remember right, this is licensed on a per VM basis that you want to manage. So what is Calm? Well, to put it sort of in VMware language, Calm is a direct competitor to vRealize automation, right? So if you're looking back and forth, you're looking to bring more automation into your environment, you're looking to be able to deploy, maintain, and support applications that maybe part of it's deployed on premises in your vSphere clusters running on Nutanix. Maybe you're in those mixed environments where you're also running some Acropolis Hypervisor, and you're starting to tie into a couple of things that are public facing. So you've got some Azure deployed VMs or some AWS deployed EC2 instances. Calm can manage those deployments and lifecycle operations across all of those environments for you. So those are all supported. So the next thing we need to think about is leveraging that distributed storage fabric. Right? If you're not familiar with the language around the distributed storage fabric, if you come from a more traditional storage environment, you're probably used to LUNs and managing storage in the construct of LUNs. We don't have that with a software-defined architecture. The distributed storage fabric is defined by storage containers. And a lot of times based on, frankly, when organizations stood up their Nutanix environment, depending on who came out to do the install, there may or may not have been a lot of time with the installation engineer. And so you got one container and they turned on compression and deduplication and they shook your hand and they said, fantastic, you're all set up, have a great day, and out the door they went. Is one container with compression and deduplication really what you want to do? Probably not, right? You probably want to do a little bit of data analysis. It takes some time. You've got to look through what's going on with the different types of applications that you run. Probably going to have to do some research, but this is a really high-level slide of different types of data set that you might be running in a Nutanix environment and the various different data storage policies that Nutanix recommends that data will perform best under. All right, so we are coming up about 25 minutes before the hour here. So let's dig into the live demo. Let's look at a few things back and forth with the Nutanix and ESXi environment. Let me make some adjustments here. All right. Apologies, I should have made one other adjustment before we got started here. Nothing like a live demo, right? Let's see if I can. Trying to maximize our screen real estate here real quick. Okay, so this should be a little better for us. So what we're looking at here is I've got a demo environment set up. We've got the desktop. And as you can see, I've got some management tabs already open here. I've got my vSphere client running. I've got a tab open to Prism Element, right? The local cluster administration interface for Nutanix. And I also have a Prism Central architecture deployed. So this becomes one of those points of conversation and frankly, sometimes a point of consternation around which management interface do I use? The reality is if you're working with ESXi as your hypervisor, you are likely going to spend most of your time still in vCenter. It just makes sense, right? It is the most likely operational space. So let's look at a few things that we need to think about when we roll this out. Folks, first of all, it's a really basic instruction, but time coordination. I would be not doing a good service here if I didn't mention the idea that my vCenter, no, yeah, wrong window, Willard, try again. Got to go to the management interface. Okay. Trust me, vCenter is set to use the same time source, the same time provider as my individual ESXi hosts, right? So time configuration is set up to use the NTP time services. The distributed storage fabric services are set up to use the same timekeepers. So when we look at the time configuration within Prism Element, you'll notice the same NTP pools set up, and I have that same configuration in Prism Central. Right? I know that's not a very exciting part of the demo, but it is critical to understand the time coordination. And hopefully you all are pretty faithful about this, but it's really critical. Especially if you're going to look at some of those advanced services like Nutanix files or Nutanix objects on top of your ESXi hypervisors, the time coordination becomes even more important. The one place where you have got to start making a mental shift is the idea of doing update and patch management from within vSphere Update Manager, or if you're already on version 7, the new Lifecycle Manager tool. That's a no-no, right? We either want to be doing that through Prism Element. All right, so looking in Prism Element, you have the upgrade software capability, and you can specify that you want to do a rolling hypervisor upgrade. And then I could update if I wanted to get to something newer. Obviously, we're well past 7.00, just happens to be what this cluster is built with. Or we're getting to the point where we can start to do some of that through Prism Central. And under the administration service is Lifecycle Manager. And so we could do our hypervisor upgrades here. Why do I care that I need to not do this in vCenter? Because vCenter has no appreciation and no knowledge of what the CVMs do for us. And folks, especially if you've got a smaller cluster configured with an RF of 2, what does that really mean? That means we're planning on any one single failure. And when you do your patching and your updating of your ESX host through Update Manager, it doesn't know or care about that CVM. And once it sees that the base ESXi hypervisor is online, it's going to start dropping the next ESX host and putting it into maintenance mode and expecting you to power down the CVM on that next system. Please be doing your patching through either Prism Element or Prism Central so that the hypervisor and the CVM get managed appropriately and you're not unintentionally creating a multi-node outage in the window. The other thing that we can take a look at here is you can see I'm actually running Prism Central inside my environment. I don't have anything else particularly exciting running. But we do have a Windows Server template. So I'm going to do a new VM from this template here pretty quickly. Oh boy, this is going to be a challenge. Zoom and its screen resolution are not being very kind to me. All right, well, let me do this from Prism Central then, actually. So from Prism Central, I can go to virtual infrastructure and say VMs. Now, the challenge here is Prism Central and Prism Element are not particularly aware or have any connection into the cloning practices, right? So this would be a create new VM environment. And I could create a Windows demo. You'll notice that Prism Central understands that I'm running on an ESXi hypervisor, so I need to get that Windows OS specified. So let's just say we're going to do Server 2016. 4 CPUs, 4 gig of memory in the short term. Build out disks. And then if I had multiple containers with different storage process or different storage services on them, right, I could pick them. We haven't done that here. We've just done so far the one default container, build that hard drive. Folks, bear with me. I'm going to have to steal this screen back to my other monitor to finish out this wizard. Live demos are never boring. And then it's time to add a network card. Again, I have just the VM network. We haven't created any others yet. And Prism Central is aware that there are different types of virtual NICs that can be provided. So we can pick the VMXNet 3 and say add. But I want to pull out an important distinction here. When I pull this down, or no, here, the only network I'm seeing is the VM network. Let me go back over to vCenter. If I just pick, let's say one of my other running VMs and say edit that VM, When I go to look at the network options here, this is one of those things that you want to kind of plan for and think about. vCenter is going to give you all of the networks that it sees in the environment, just like it always has. And what you get, what you saw with Prism Central is that backplane network and the iSCSI port group, that backend network between the hypervisor and ESXi, those get filtered out. Right? So Prism Central, frankly, puts some guardrails around. And especially if you have maybe newer admins that aren't really familiar with the distributed storage fabric architecture, you might want to start them in Prism Element or Prism Central, because some of those Nutanix specific guardrails are already going to be there. They're going to be built into the user interface for you in that regard. And then the last thing I want to do is I want to take a look at storage, and then we'll open for open Q&A. Folks, also, hopefully your installation engineer had time and walked you through what you're seeing here. You'll notice we've got a series of NTNX local data stores. These are the data stores that are the local boot image for each ESXi node and house the CVM. Right? So these are off limits for general deployment. You should not be using those for any storage. You have the default container, which is built when the cluster gets installed. And you can see this is where I built that Windows Server VM. I have built an ISOs directory and put my Windows Server ISO out there. But how do I create a new data store? Right, that is done through your choice, one of the two Prism interfaces. I'm going to go to the Prism Element interface because a lot of you may have not deployed Prism Central. And so here's the other thing, right? You see there's the default container. We've got a management share. We've got a self-service container, but those don't appear in VMware. Right? Those are reserved for Nutanix functionality, so we don't mount them to the ESX host by default. But if I want to create a new storage container, let's call this without compression. And then I've got my choice of how do I want this to be handled on my ESX hosts. Right? Your Nutanix distributed storage fabric is presented to your ESX host as NFS shares. So we're going to say mount to all. I want to take a look at my advanced settings. And I am going to turn off compression on this particular container. And when I hit save, it runs through, it creates the new container, and then confirms that it was able to mount that on all three of my hosts. So now if I go back over, I'm now back in vCenter, and my container without compression is already there. So if I had a particular workload that should be built in a data environment where the back-end system is not already running compression, right? What's a good example of that? How about any SQL or Oracle database volume? Right? Today, most modern databases run an in-application compression model. So I don't want to be trying to do compression of that data twice. I won't get any extra efficiency out of that. And so it lets me build the right data services around those specific types of workloads. And then by simply creating the storage environment in Prism Element, it automatically gets created. Well, how does it automatically get created? If we go to the settings for Prism itself, I have the ability to register to Prism Central, and I have the ability to register to vCenter. So I've already put administrative credentials in the Nutanix management platform that lets it talk to vSphere. If I go back over to my vSphere environment, if I can get the mouse to cooperate, it's already rolled out. We could have potentially, if I'd have done it faster, we would have seen the initiator would have been com.nutanix, and it would have executed that mount on all three of those ESX hosts. So just a little bit on how you've got three different management interfaces. By and large, like I said, I suspect most of you are going to stay with the vSphere client, but Prism Central is very vSphere centric and has the ability to have those sort of Nutanix specific guardrails. And so I'll finish up this workflow, creating my new VM, right? It's now configured as that Windows demo VM. I've added the network. I'm going to have to slide this back over to the other monitor just for a minute to get my resolution back, because I want to finish this workflow. I just hit save. And so I created a new VM called Windows Demo, and I did that from Prism Central. And now if I go look at my virtual machine inventory, there it appears, right? Because I've set up the credential relationships, I can do my management from any of the three platforms. So folks, other things that you have thought of, questions that have come to mind as we've been talking about the Nutanix and VMware interconnection with that ESXi Hypervisor and the distributed storage fabric services or the management planes.
Ken, I would like to second that, inviting everyone in the room to post their questions or comments in the Q&A or the chat window, both found at the bottom of your screen. With one eye on our time, as those questions are coming in, I'd also like to talk about why you should choose ExitCertified for your Nutanix training. So professionals like you have been training with us since 2001, and today ExitCertified is the only Nutanix premier authorized training partner in North America. We're proud to commit to the largest Nutanix guaranteed to run training schedule in North America, and you will be able to distinguish which classes are guaranteed to run when you see the GTR stamp on our schedule. Another great asset of why you should train with ExitCertified is that we offer a 1-to-1 ratio of student lab infrastructure. That means no shared clusters or team labs. You get your own environment to work in. I spoke about a public training schedule, and I'm going to leave a link in the chat window for everyone here. Not only are you going to see our Nutanix schedule, but you will also see the option to contact us if you do have any questions. And if you need any more convincing about why you should train with ExitCertified, we are offering a webinar exclusive savings. This opportunity will give you 15% off virtual or classroom training, or 10% off on-demand subscriptions and self-paced courses. You need to register by November 30th. And to find all of the details about this promotion, check the link which I just left in the chat window. Awesome. We have a question in the Q&A.
We do. Good question, actually. So the question is, because I don't know who's got the Q&A window open, but the question says, if we have VM disk latency alerts for a VM that's running on top of ESXi with Nutanix, where do you start troubleshooting that, right? Are you looking at ESXi or are you looking at Nutanix? I would tend, if it's disk latency, I'm going to start with Nutanix. Here's why. When you think about what those CVMs, those controller VMs do for you in your environment, trying to draw some parallels again to maybe a traditional 3-tier architecture. We think about those external storage area networks or network attached storage platforms as having communication endpoints called storage providers. When we think about what's happening in the Nutanix hyperconverged architecture, the CVM is our storage provider, right? It is that communication endpoint for us. And you shouldn't be having any kind of latency between ESXi and your CVM. And the reason I say that is because if we go back and take a look at the configuration, I'm going to go to my hosts, and I am going to look at their virtual switches. And again, I get this is a little bit of an eye chart, but if I scroll down, you will all have in your environments this vSwitch Nutanix configuration. You'll notice it has no physical uplinks associated with it, right? It is a private communication internal to that host only that the ESXi Hypervisor. So if you look at this, you've got the CVM and you've got a VM kernel port defined. And by the way, folks, don't let this throw you. I know they label these iSCSI. ESX does use NFS to communicate with its storage from Nutanix. So when we think about that communication, there should be no network latency between the host and the CVM because they're local to each other, right? That CVM is running on that host and that is internal traffic. So if you're having some disk latency issues, you're going to want to start looking at the CVM and find out, is that CVM overworked? Is it maybe undersized? Right? If these are things like it's read latency, you might want to allocate a little more memory to that CVM so it can build a little more read IO cache. Right? But assuming that there's nothing that's been modified, that's one of the other things. You should never, ever modify that vSwitch Nutanix in the architecture. So assuming that that's true and nothing's been modified or misconfigured with that switch, I'd look to see if maybe allocating a little more resource to the CVM would help that. The other thing I would always tell you, hopefully you've had the experience, but if you've got a question, open a support ticket, right? Nutanix support is fantastic at working through these things with you. Great question. All right. Second question, where would you do software and firmware updates for the hosts? Again, I would be doing that through either, if you're not going to deploy Prism Central, I would be doing it through Prism Element, simply because of the reboot cycles on those scenarios and the fact that vSphere Update Manager, even if you're doing something like other vendor software patch into your ESX host or firmware updates, it's not going to necessarily wait for the CVM to completely come back online and start all of its services before it tries to move on and get the next host to go into maintenance mode. So you could either put yourself at a situation where you've got too many hosts down from a resiliency standpoint, and certainly you could create some congestion on those hosts that are still up and running, depending on how big your cluster. So yeah, software and firmware updates for hosts, also through Prism. Another good question.
Thank you, Ken, and thank you everyone for attending today. We have reached the end of our webinar. As mentioned, we will be following up with an email in the next few days where you will also receive a copy of the recording. If there are any questions, we want to encourage you to contact us. I'll leave our site once again in the chat window. Do reach out with any questions. And thank you, Ken. Excellent job. As always, enjoy the rest of your day, everyone.